Good morning everyone. Today again we are here to continue our topic vapor pressure. It is the topic of chapter 1 class 12 chemistry solution. Okay. So we should know the definition of vapor pressure. So before doing this definition, okay, first we should know what is the escaping tendency. Okay. Escaping tendency means how much particles can evaporate. Okay. Suppose we have taken the example of ethanol in a container. Okay, if it is taken in open container, then all the molecules that has evaporated, it will enter into the atmosphere. Okay, so we can't measure the vapor pressure of that solvent because all the molecules has entered into the atmosphere. So we have to take the closed container. Again we have taken here the ethanol. Okay, if it has capacity to escape, the molecules has capacity to escape, it means it can exert a pressure. Okay, it has capacity to form a vapors. So one term we will do here before doing this definition, that is equilibrium. Okay, this word is written in the definition. What is the meaning of equilibrium? Okay, in equilibrium you can take some constant property here. Okay, but how I will explain you. Suppose 20 molecules of ethanol you have taken in a container. How much molecules it is? 20 molecules. Okay, slowly it will evaporate. Initially 2 molecules evaporate, then 2 more, like this 2 more. Okay, finally how many molecules has evaporated? Suppose it is 12 molecules has evaporated out of 20. Then how many molecules left here? 8 molecules. Now here equilibrium has attained. Equilibrium means now the ratio between the 12 and 8, it will remain constant. Okay, it will remain constant. Now after attaining the equilibrium, if 2 molecules will evaporate now, at the same time 2 molecules will come back. Okay, again the equilibrium, because it has attained the ratio between the 12 and 8, it will remain same. Okay, so we can say after attaining the equilibrium, every time same molecules will evaporate, at the same time the same number of molecules will condense. This stage it is called equilibrium. At this stage it is called equilibrium. So we can measure the vapor pressure. How we can measure? We can measure the vapor pressure only at equilibrium position. Okay, so at that time how many molecules was there? Total it was 12. So how much pressure is exerted by these 12 molecules? That is called vapor pressure at equilibrium. Okay, so now we can define the definition properly here. At a given temperature, definitely some temperature was there. Okay, the vapor pressure of the liquid is the pressure. Okay, vapor pressure of the liquid means that molecules that has evaporated, they have some pressure. Okay, in equilibrium with the liquid solution. With the liquid solution, why they told with the liquid solution? Because in liquid solution it was having 8 molecules. Okay, now they have equilibrium between 12 and 8. At that time whatever the pressure exerted by the vapors, this is called vapor pressure. So we can say vapor pressure is directly proportional to escaping tendency. Okay, one more example you can tell very easily. Suppose we have taken water and ethanol. Okay, so you all know very well about ethanol. Okay, we are using for drinking purpose also, and it has strong tendency to escape as compared to water. So which one is having more escaping tendency? Ethanol. Then which one will have more vapor pressure? Definitely it is ethanol only. Okay, so it means we can say that if it is having a more tendency to escape, then it has more vapor pressure. So next term we will do here, vapor pressure of liquid solution and Raoult's law. Okay, so if you will take the mixture of two liquid, then on that we can apply the law, that is Raoult's law. Okay, but one condition should be there, both should be volatile. Then what is the meaning of volatile? Which has capacity to evaporate. Okay, so volatile means which has capacity to evaporate. Suppose we have taken wax and water. Then which one is having a more capacity to evaporate? Water. Then water we can say it is more volatile as compared to wax. Ethanol and water. Already we have taken this example. Then which one is having a more capacity to evaporate? Ethanol. Definitely ethanol has more volatile nature as compared to water. So this law is very important. Okay, in many times in board exam it is coming. Okay, so Raoult's law, what is that? Actually what it states that the partial pressure of each component in a solution of volatile liquid is directly proportional to its mole fraction. Before doing this definition, we should know what is the meaning of partial pressure. Okay. So one example I am taking here, suppose you have taken two liquid, it is water and ethanol. Okay, it is water and ethanol. Okay, now both liquid you have taken in this container. But which one is having more capacity to escape? That is ethanol. But it should be closed. Okay, then more vapors you will get of which one? Again I will make this diagram. You have taken a closed container. In that ethanol plus H2O you have taken. Okay, which one is having more capacity? That is ethanol. Then vapors will be formed of which? Ethanol. Okay, and water also. So we can say that in liquid state, molecules of ethanol and water both are present here. Okay, and in gaseous state also molecules of ethanol and water present here. If any molecules in gaseous state it is present above the surface of liquid, then we can say this is the mole fraction in gaseous state. Okay, that is represented by Y. If molecules in liquid state it is present here, okay, then we can take mole fraction in the symbol of X. Okay, so we can explain again what is the meaning of Y and X. Y, it is the mole fraction in gaseous state, or you can say in vapor state, and X, it is the mole fraction in liquid state. Okay, so you can see this is the liquid state and this is the gaseous state. Y, E and Y, W.